Okay, so yesterday we said to prove shapes are similar, we need a sequence of rigid motion transformations and dilations. Rigid motion transformations. Now my pen's not going to work. And dilations that map one onto the other. If they are similar, now we can start talking about those things that you guys were saying. All the angles, all corresponding angles. Are congruent. And the big one, the one that we're going to focus on today, the one that really makes a difference to us right now, I'll put it over here a little ways. The ratio between corresponding sides is always the same. Okay. And that might be actually all we have to write for notes, but let's try a couple problems. So leave your notebooks open and let's just look at some examples here. Okay. Can't tell if people are still writing or not. Many people glazed over. If I have these two triangles and I tell you that these two triangles are similar, this is our similarity sign. It's like a tilde kind of. Which angles would have to be congruent? Well, in this example, they tell us P is congruent to U. Notice the order still matters. P is congruent to U, so I can mark these as congruent. Q is congruent to V, so maybe I'll mark those with double congruence. And then W would be congruent to R. What this also means is that all of these ratios of corresponding sides are the same. So if I took the measure of PQ and divided it by UV, it'll be the same as dividing any of the other sides. So remember, in general, our ratio will be image over pre-image. The more consistent we can be, the easier things will be for us. So if we look at this trapezoid here, which angle measured would be congruent to angle B? Gavin Hart? I got you. Good. I know this stuff isn't always exciting. Let's get through it, though. The faster we get through it, the less of it we have to do. Juliana? Angle F. Thank you. What is the corresponding side to side AB? Katie? EF. AB and EF. So as a ratio, I would write EF there. What is the corresponding side to HG? Gavin Hart? HG is DC. What is the corresponding side to CB? Somebody I haven't heard from. Yeah, I can scoot over. That's fine. Megan? GF. For the last side, which one would go on top? I see your hand. I will raise you, Caitlin's. A, which one? AD. Yeah, AD should go on top. We're going to say that this is my image here. So AD goes on top, and then which one goes on bottom? Tim. EH. And if these were all numbers, all of these numbers would be the same if I did this division. Nothing too complex there, right? Let's keep going here. See if we can answer these last questions. What is the measure of J? What do you think, Gavin Hart? Angle J.
Wait, yeah. Wait, no, I'm dumb.
Let's ask this first. Which angle corresponds to angle J? King, which angle corresponds to angle J? Angle R corresponds to angle J. Do I have the measure of angle R? No. How do I find it? Kobe. Good. So I get 180 minus 110 is 70. So this is a 70-degree angle here. So what is the measure of angle J, Hayden Kaiser? If this is 70 and these two angles are congruent, what is the measure of this angle? 70. I suppose it's just 70 degrees. If I want to find ST, how do I find ST? Start picking on people. It's too quiet. Taylor, help me out. Which ratios would I have to set up? Okay, quit cheating. Now tell me how to do it with ratios. Good. So here's what you said. 3 over 9 has to be equal to what? 4 over whatever ST is, right? This is how you found it in your head. Okay, you just cheated. How do I figure out what ST is? Caden Nielsen. Sure, you can reduce it to fractions, and you can say, well, this is all equal to 1 over 3. So if 1 is 4, then 3 times 4 is 12. And that's probably more like what you did in your head. Okay? But yes, ST should be 12. It's important to recognize, though, because sometimes we're going to throw some variables in here, and you'll have to understand that if I say that this is x plus 1 and ask you to solve for x is not 12, x is 11 here. Okay, so we would actually have to multiply some of this out. What about JL? What is JL? What do you think? Maybe I'll pick on somebody who's not looking. See how many people look. Maddie Dalton. Yeah, how'd you get 5? Doing that stuff? Yeah, good response. How else could you get 5? Juliana. What's that? 15 divided by 3. Good. That's a good way of doing it. How else could you do this? Gavin Hart. Yeah, the Pythagorean theorem. This is a Pythagorean triple. 3, 4, 5 is a Pythagorean triple. Okay, so there are a whole bunch of different ways to do that. We're still under 9 minutes. Let's do a couple more because it might just be worth it. We're looking at number 1 here to start. Find the error. TUV and XYZ are similar. What is wrong with this statement? What is wrong with these things here? Donovan, go ahead.
The last one is flipped upside down.
Yeah, this last ratio, XYZ is supposed to be on the bottom the whole time. You can't flip one of the ratios, so this is flipped. Cool. Number 2. These two triangles are similar. Write three proportions relating the triangle's side lengths and three statements about their angle measures. I'm going to call on 6 different people here. You have to be able to give me one that's not up there. I'll give you a second to think. You can give me an angle or a side length ratio. Let's start. Ethan Wright. Can you give me one side length ratio or angle? Hashtag no. Which angles would have to be congruent if CDE is similar to FGH? All right, maybe we need to start listening then. Who can help out Ethan here, Grace? Angle C would have to be congruent to which angle? Angle F, because they are corresponding. By name, they are corresponding. C is congruent to F. Somebody else give me another pair of angles that would be congruent. Let's see. Go ahead, Landon. Good. Angle D would be congruent to angle G. And Ethan, what's my last set of angles that would be congruent? E and H. Angle E would be congruent to angle H. What about side length ratios? Let's start by writing 1, and let's see if somebody can pick up the pattern from there. Go ahead, Jason Gruber. Give me some side length ratios. Good. I've got CD over FG, and this would have to be equal to which other ratios? Who haven't I heard from in a bit? No. Clarissa, can you help me out? Good. Yeah, go ahead and stop with that one there. We'll let somebody else write the last one. Go ahead, Kane Nielsen. EC over HF, that'll work. Okay, can we write all 6 pieces? Are you guys confident enough with that? I don't have to continue to pick on you with that? Okay. Let's see. Are all rhombuses similar? What is a rhombus? Donovan.
Quadrilateral where all side lengths are the same.
Good. So if I have 2 quadrilaterals where all the side lengths are the same, are they all similar? Why would they or wouldn't they be? Donovan, you see? Go ahead, Kevin.
No.
No. Let's see if we can come up with a counter example. Is a square a rhombus? Can you draw another rhombus that would not be similar to this? And what do we mean by not similar? Donovan?
They do not have the same angle.
Yeah, could I change any of these angle measures and still make it a rhombus? Yeah, boom. Bow, bow. Bow, bow. It's still a rhombus, but they're pretty clearly not the same shape. Let's take a look at this diagram here. Explain why triangle CBD is congruent to CAE. Why is this large triangle congruent to this small triangle? Here's some important information. If these lines are parallel, what kind of angles are these? What kind of angles are they? I got all 3. Two parallel lines. Draw parallel lines then, that's fine. Got two parallel lines. And they're cut by this transversal. I want this angle and this angle. What kind of angles are those? What is the relationship between them, Juliana? Good, they're corresponding. So I know that angle E and angle D are congruent by corresponding angles. Could I say the same thing about angles A and B? And isn't C congruent to itself? What property tells me C is congruent to itself? I guess we'll write these out. That's fine. We're good, guys. Angle A is congruent to angle B by corresponding angles. And we could say the same thing for angle E and angle D. What tells me that angle C is congruent to angle C? If it's something that you just do automatically, what do we call that? Caitlin? Yeah, good. This is the reflexive property. Okay. Let's find CE. We might as well. We seem like we could use some work here. So here we go. I know that BD compares to which side length? Which is the corresponding side of BD? Maddie. AD. So I can say that BD over AE is equal to, and let me put in the numbers now, 6 over 14. And they want CE, so they want this side here. This has to be equal to which ratio? Which is the corresponding side of CE in the small triangle? So CA would be the opposite side of the large triangle. I want the corresponding side of the small triangle. Juliana? CD. This will be equal to CD over CE. Because those are corresponding sides. And now I know what CD is. Well, this is 20 over, let's call it X. I can multiply it by 14 and then divide by 6. And it doesn't work out real nice. But we can guess 14 times 20 is 280. 280 divided by 6 would be something like 47. Yeah, 46.8. I don't know, approximately 46.8. Do we need to go over how to solve proportions? How close was I? Did you check it?
You're like
Yeah,
20.
well, it's right there.
How much? What's the actual number?
It's 4.6.
It's
Large.
46.6 R.
All right. So 46.6. That's fine. I'm good with that. Can you ask any questions about this stuff, guys? I felt like that was oh, yikes.